Hello and a very warm welcome to everyone. And thank you for joining in for our webinar on top engineering considerations to build and scale edge AI and autonomous machines featuring Silas, Somasundaram and Margaret. So during the webinar, if you have any questions, please type them into the QA box. We will take them at the end of the webinar. Now, I will hand over my mic to Silas, who is responsible for sales and business development in US, and he is going to walk you through the agenda and introduce two speakers as well. Over to you, Silas.
Thanks, Kaushal. Hello, everyone. Good afternoon. And thanks again for taking time to attend this informational webinar. We hope this will be valuable to you. My name is Silas Mark. I'm located in Boston, and I'm responsible for the engineering services business development for the Edge AI and autonomous machines segment at eInfochips. I'm joined by two other colleagues from eInfochips. Santosh Shiva is a VP at eInfochips. He leads the Edge AI and autonomous machines segment. He is also responsible for the autonomous machines Center of Excellence and global strategic partnerships. Also joined by Soma Sundaram. He is the data scientist at eInfochips. I'm also joined by our guest speaker today, Margaret Mori from NVIDIA. Margaret is the Inception Regional Manager for North America at NVIDIA. And thanks, Margaret, for taking time to join this webinar as well.
Thanks for inviting me.
Thank you. eInfochips and Arrow have a strong partnerships with NVIDIA, and we together are solving problems for customers in the robotics space. I also thank Mass Robotics for their support for this informational webinar. Mass Robotics has been doing a tremendous job in the Boston area to support the startups focused on robotics and connected devices. Arrow is one of the founding members of Mass Robotics. And today we are excited with the opportunity to add value to Mass Robotic residents and other companies that are attending this webinar today. As I said, this is an informational webinar. We will talk about the market trends and customer imperatives. We will talk about the key design and engineering challenges faced by robotic companies, edge AI and autonomous machine companies, and some of the solutions to help address these challenges. We will also talk about some key offerings from eInfochips and NVIDIA that can help you. And then we will open up for Q&A. So edge AI and autonomous machines are definitely revolutionizing multiple industries. It's improving quality of life. It is bringing safety for people. And innovators like you are the reason for this revolution. And this is what we are noticing in the market today. There is a huge, huge market opportunity and growth for AI and autonomous machines and robotics companies. The market is close to $170 billion, and this market is growing over 20% annually. And over the last couple of years, we have also seen more than 2,500 autonomous machines and robotic startups, being funded, and over $42 billion of funding has come in from investors for this particular space. I guess some of you on this call may be part of this startup community, and we are delighted to be connecting with you all today. So with market demand increasing exponentially for robotics and autonomous machines, for companies to be successful in this segment, I think it's imperative for companies to accelerate time to market, to reduce R&D and customization costs, and to leverage strategic engineering talent from a global workforce without the ballooning costs. Arrow Electronics and eInfochips is well positioned to help you in these areas. And we will talk some of those details today in the webinar. With that, let me invite Santosh to give a short overview of eInfochips and the Autonomous Machines Center of Excellence. Over to you, Santosh.
Thank you, Silas. Good morning, good afternoon to everybody. And can we move on? We can move the slides. So, quick overview about eInfochips. We are really an engineering design services company with over 3,000 people, and we've been in business for 25 plus years. Our core engineering, core competences in the area of really being able to build devices right from hardware up software and into integration into cloud, really the edge to cloud competency that very few engineering companies bring to the table. We're part of Arrow Electronics, which is a global leader in electronic components distribution, and eInfochips functions as the engineering services arm for Arrow. Let's move on. So really why we are here is because our focus and investment in the edge AI and autonomous machine segment. And what eInfochips and Arrow is doing is three major aspects to put together a center of excellence that we believe will help OEMs that are building robots and autonomous machines to get to market faster. So these three elements are essentially, one is our partnerships with incubators like Mass Robotics and MIT Engine. So where there is innovation happening at a revolutionary level, where entrepreneurs are coming up with ideas to build the next level, next set of autonomous machines. So our partnership with these organizations, so we can help them enable the engineering activity. The second part is platforms, such as NVIDIA or ADI, who we are closely partnered with, who are building the building blocks that help engineers build the next generation autonomous machines. And all of this needs to really work together. You have the platforms, you have ideas, you have multiple components that make up software, hardware, and that's where eInfochips Center of Excellence comes in. We have a center of excellence that has engineers that are trained in the area of ROS, in the area of data simulation, synthetic data creation, in the area of hardware design, such as using a platform like Jetson, which really accelerates edge processing. So we're working with all of these different elements and bringing together in one lab that folks like you can leverage. So that's really the background for Center of Excellence. And so yeah, let's move forward and let the team talk about what we're here to speak about. Thanks, Silas.
Over to you, Soma.
Thank you, Santosh and Silas. Next slide, please. So let's talk about a few of the challenges that we face in the AMRs. AMRs are used in various applications like the warehouse robots, the medical robots assisting the operations. They play a vital role in their respective fields. However, developing such AMRs is not an easy task. Let's see three of the major challenges involved in developing such an AMR device. Processor selection. As AMRs require a lot of computing power, a powerful processor for computing AI models along with interfacing all types of sensors is a challenge. There are edge devices that are specifically designed and developed for such applications, which can handle multiple interfaces along with computing AI models seamlessly. Data plays a critical role in training the AI models. More the data that we have, better the model performance. However, data collection is a time-consuming and tedious task. To overcome this problem, we can use synthetic data sets, which can be generated by using GANs. The autonomous machines, testing of these machines has its own set of challenges, like the need for an end-to-end testing from sensor to cloud, industry-specific test requirements, and real-time environment simulation or virtualization. AMR development happens in silos, from hardware selection, simulating the AMRs, then developing and deploying the AI models to testing it into the actual environment. AMRs might need to work in a warehouse or a factory or a grocery store. In most of the development cases, the hardware is not available the initial part of the cycle. So it's a big challenge to test the AI model initially. There are some leading simulation softwares which will create a digital twin like the NVIDIA's Isaac Sim or the Omniverse platform as a solution for this problem. Next slide, please. For AMR applications, there are various factors which determine platform selection. Let us see few of the factors. Compute capacity, which is correlated with the number of CPU cores in the SoC, the clock rate, the DDR bandwidth, and the amount of L1, L2 cache. More the compute capacity, faster the processing. An image signal processor is a dedicated processor that takes the raw data from the camera sensor and converts it to a workable image. The image signal processor helps to tune and grab the image as per the requirement in a seamless manner. There are special hardware encoder and decoder accelerators called as on-chip accelerators for H.264 or HEVC formats on the edge devices. These accelerators help to transmit data much faster than the conventional methods. The edge devices may come with inbuilt GPUs and AI accelerators, which are specifically designed to handle billions of mathematical operations from the neural network. We can execute the neural network much faster in the GPUs than executing it on the CPU architecture. Input-output interfaces. The SoC for an AMR device should provide various input-output interfaces such that all the associated peripherals can be attached natively to reduce the bill of material cost of the overall solution. There are specific AI accelerator toolkits. For example, the TAO toolkit provided by NVIDIA helps to optimize and deploy the AI models on the edge devices. There are even pre-trained models, like models used for people detection, vehicle detection, which can be directly deployed on the edge devices without the need of even model training. Apart from this, there are special requirements, like the AMR-based product may require to be certified for various regulatory compliances, such as FCC CE. Selecting edge devices, which already provides various compliances for many countries, saves a lot of time, effort, and cost. Next slide, please. Now let's see, how do we design a data AI pipeline? How do we begin a project? Before commencing any of the AI-based project, we do a detailed study on the customer requirement and explore the literature for similar kind of work. During the literature survey, we get an idea about the feasibility and the efforts needed to successfully execute the project. Then we start to work with the data. Data plays a very critical role. The data can be prepared from scratch, or we can use the data set provided by the customer. Data preparation steps like data labeling, annotation, pre-processing the data are carried out in this section. After the data preparation, we select the model. The models are selected depending upon the application, throughput, or FPS expected. Initially, we check for readily available open source models that can suffice the requirement. If it's not available, we develop our own model architecture. After the model architecture selection, we train the model using the pre-processed and the labeled data from step 1. During the training process, plots are generated to achieve the model convergence to avoid overfitting and underfitting of the model. Once the model training is completed, we use the trained model as a frozen model. This frozen model is quantized and pruned to achieve the best throughput performance. As the optimization process, may lead to drop in accuracy, the throughput accuracy trade-off is checked before the model deployment. The model is deployed on the edge device on the suitable runtime like GPUs or DLAs, and the performance of the model is benchmarked. The output of the model is either fed to cloud or visualized and stored locally as per the requirement. Next slide, please. We have seen about the model training and deployment pipeline. So now let us see few of the steps, few of the models used in the edge device. As we discussed, data generation, data collection is a very tedious and a critical task. AI models require tens and thousands of images for training the model. Collecting this model can be very much time consuming. Generative adversarial networks, called as GANs, help us to create synthetic data sets. These data are artificially created data by using this network, but these data sets look real and same as the actual data sets. Simulating the navigation in the autonomous robots. Autonomous mobile robots must move in their environments from point A to point B. Before deploying the robot in the actual environment, it must be tested in a simulation environment, where the platforms like Isaac Omniverse comes in handy. One of the key application areas for robot is for manipulators, which can identify objects, pick them, and move them. In a modern factory or warehouse environment, manipulators can greatly increase the efficiency and throughput of handling and sorting materials. Manipulator simulation toolkits must be used to simulate common tasks like filling and stacking bins. AMR devices use different neural network models according to the applications. Some of the widely used network models are the detection models, the segmentation models, and the landmark estimation models, as you could see in the right-hand side of the slide. The detection models identify the object present in the input image. Also, it localizes the object by drawing a bounding box. This figure shows the example of a face detection algorithm, detecting the faces and drawing a bounding box over the face that we had developed. The landmark estimation model helps to identify landmarks in the form of XY coordinates from the given input image. For example, in the given picture, we could see the joints of the human body are identified in different body postures. Segmentation models are a bit more complicated compared to the other two that we have seen. Segmentation models designates each and every pixel to a particular class and create masks for each object with pixel level accuracy. Training and deploying these kind of models is a challenging task. To ease this process, transfer learning toolkits can be used like the TAO toolkit provided by NVIDIA. The picture in the middle shows an example of the transfer learning process. If a model is trained for task A, by freezing all the layers except the last few layers, the model can be trained for task B. This will reduce a lot of training time as the model has already been trained for weeks or months for task A. Next slide, please. After the model training process, after we achieve the accuracy that we are expecting, we need to deploy the model onto the edge device. We might have trained the model on a cloud environment where we have a lot of computational capacity. We might have multiple GPUs to train the model. Whereas when we are trying to deploy the model on an edge device, in case of an AMR device, we have limited computational capacity. For example, we might have limited GPUs and DSPs. So we need to make sure whatever we deploy, we must have deployed in an optimized fashion. During the training process of AA model, we use either floating point 32 operations or floating point 16 for the training process. But during the inference stage, we have the discretion to change the floating point operations. That's what we call it as a quantization. So in quantization process, we reduce the floating point operation from 32 or to 16 or from 16 to integer 8. This will help us to do the mathematical operation in a faster fashion. We also check for layers that are not needed during the inference stage. So we can check the activations that are happening in each of the neural network. If their activations are low in few of the layers, we can remove those layers, which are nothing but the unwanted layers, which are called as model pruning. We can do fine tuning. For example, in case if it's needed, we can remove unwanted layers. That will help us to improve the inference speed, which in turn improves the frames per second. We can even check the memory consumed while storing the model. Also, the data transmission rate from the camera to the edge device, to the SoC, and the output. Optimization of this data flow will help us to improve the throughput. By following these steps, we can achieve an optimized model and we can achieve the best performance from the edge device. Next slide, please. After deploying the model, testing is a very critical task. We need to test the AMR device onto the environment so that it doesn't fail. I request Santosh to walk us through the testing environment that we follow.
Yeah, thank you, Soma. One of the challenges that we are hearing from our customer base is the complexity of testing a robotic system. And like all complex systems, robotic systems have multiple layers and multiple development initiatives that lead to challenges. So the most basic level, you have the embedded layer, you have the hardware, the basic, the hardware that's powering the device, the AMR. And here we have seen the need to test and automate and virtualize the hardware layer. So the second layer is the application layer, where the software is interfacing with the outside world, the HMI systems, the cloud environment, and the need to send data to the cloud such a way that the data that is being collected by the sensors is being processed correctly and is analyzed. So that's the second level of testing that that we see is a necessity and is happening in silos. And here we're looking at things like the virtualization of the edge system itself, the edge UI automation, having the right level of framework to automate these repeated test cases, the functional testing for these devices, as well as the HMI interface and the mobile interface to the robotic system. And the last part that is emerging most recently is in the last 5 to 10 years, the systems that have been developed, the robotic systems that have been developed, had the luxury of development and deployment, collection data, retraining, and then having a closed loop testing for optimization, both as a functional unit as well as how it behaves in a customer environment. But as we move forward, the time to market is shrinking with a large number of robotic OEMs out there, and that's where we have the options of simulating and creating synthetic data. And platform companies like NVIDIA have powerful tools like Isaac Sim and Omniverse that allowed you to create a digital twin of your existing robotic system and simulate it in an environment that allows you to collect synthetic data, bring it back, and then retrain your models. So from a need perspective, we believe that as a QA center of excellence needs to be a team that can bring all of this together. You have silos of unit testing happening at each of these layers, but then you need to have all of it working together for the robots or the AMRs to function successfully in your customer environments. So what does the COE for QA look like? So one is, there are 3 major processes involved. One is the assessment phase, just getting to the base level of what is the current state from a unit testing point of view, whether it is on the embedded side, on the application silo. And then, of course, the deployment side of it, where you're looking at customer environments. So the first level is assessment, the ability to collect the current state, creating the foundation for product testing, and creating also the automation strategy for automating to the level that you can automate. And we have seen that almost 50% of test cases can be automated in some of these silos. The second level is creation execution. So one, the automation framework is established. Once you are able to automate your test cases, then you get into executing these test cases on an ongoing basis and recording the bugs and creating a closed loop system so that you can collaborate with the development teams. And the last part is really the customer side of the equation, which is to simulate and create digital twins of the fully finished robotic system and being able to deploy it on a virtual environment and create synthetic data, which creates a closed loop to bring it back and optimize for the next level of modeling. And at this point, I'd like to hand it over to Margaret, who's from our partner teams in NVIDIA, and she will talk about some of the platforms that NVIDIA is creating to create an Omniverse, which is a virtual environment that helps in creating synthetic data and enables this testing process right from system to customer environments. Margaret, over to you.
Thank you so much, Santosh. So I'm just going to kind of jump right in. I have a handful of slides I wanted to share with you guys, and they're really on two separate subjects. So as Silas introduced me earlier, I lead our North American Inception region for NVIDIA. So I will talk about what is Inception and how does it support robotic startups. But first, I wanted to talk a little bit about some of these tools that Santosh described for creating these virtual robot training environments. And to kind of even take it a step further, I wanted to first set a little bit of context about what informed the creation of these things, of these tools for roboticists. So it's really a couple things. One, NVIDIA has a very kind of high and broad view of the developer landscape, right? So we see across millions of developers, hundreds of use cases, and dozens of industries. So that's one thing, this kind of high vantage point. The second thing is our own work, our own development work. So a lot of these tools that we've created are because we find them useful in our own development work for our autonomous driving software stack, for example. And then the third is everything that NVIDIA does is very forward-looking, very future forward. So we believe that moving forward, we'll be in a world soon where everything that is built in the physical environment will have first been built in a virtual environment, and everything that moves will be automated. And you can kind of combine these two things where these automated things can have been trained in the virtual simulated environment first. So with these three things in mind, we've built the Isaac platform. This includes all of the different components that you need to develop a robotics application. So a lot of the things that Soma touched on before with the AI pipeline, we've got great tools for you to address them. So starting on the left, and I'll just kind of touch on each one here real quickly. Starting on the left, from a data prep standpoint, we've got Omniverse Isaac Replicator, which allows you to really very easily generate synthetic data, as well as to the creation of simulated environments for AI training with Isaac Sim, which I'll tell you a little bit more about in the next slide. To speeding up the development of your AI models with Tau Toolkit. Tau is train, adapt, and optimize. TensorRT is a favorite optimization engine for all different types of models. It makes your models super lightweight and easy to deploy on edge hardware, such as NVIDIA Jetson. Moving over to the development bubble, Isaac ROS Gems really simplifies the development of GPU accelerated ROS2 packages. We've got DeepStream for image processing and Riva for language. And then finally, in the deploy bubble, we've got Triton and Fleet Command. So Triton is essentially a model load balancer that works across both CPU and GPU. And then Fleet Command offers you a really easy way to keep your models up to date once they've been deployed out into the field. So all of these tools are free for NVIDIA developers, and many of them are open source as well. And as Soma indicated earlier, eInfochips often uses a lot of these tools in some of the work that they do. So you can go to them with questions as well. Different examples of partners developing on Isaac Sim. Fraunhofer IML, a technology leader in logistics, uses Isaac Sim for the virtual development of Obelix, which is a highly dynamic indoor-outdoor autonomous mobile robot, or AMR. After importing over 5,400 parts from CAD and rigging with Omniverse PhysX, the virtual robot moves just as accurately as it would in the real world. So obviously this would really accelerate the development and then allows you to really scale to other scenarios as well. Festo is well known for industrial automation. They use Isaac Sim to develop intelligent skills for collaborative robots, or cobots. This requires acute awareness of the environment and the human partners, right? To be able to work safely in close contact with other humans, you need to be able to test this in a very scalable way. And this is deployed at massive scale across a variety of different environments. Finally, there's Animal, which is a wheeled quadruped developed by a leading robot research group from ETH Zurich and SwissMile. Using end-to-end GPU accelerated reinforcement learning, Animal, whose feet were replaced with wheels, was able to learn how to walk over urban terrain in minutes rather than weeks. They did this using the NVIDIA Isaac Gym tool. The locomotion policy was verified in Isaac Sim and then deployed on a real animal. This is a great way to demonstrate the simulation training for real-world deployment. So basically across these three different examples, we're trying to show from training perception to policies and hardware in the loop with Isaac Sim. This is a great tool for you guys to leverage to build AI-based robots. And next slide. So this is a great example of, who else is building on Isaac, right? So we kind of dove into three specific examples in that great video, but we're seeing massive momentum across the robotics market. We've got leading partners in last mile delivery, agriculture, retail, smart warehousing, healthcare, and beyond. And I think what I love to point out here for you guys is that this is not just manipulation, but navigation domains as well. And then, what I personally love about this slide is you'll see a number of different robotic startups that NVIDIA works with. It's not just the really big companies that we always evangelize, like Yamaha or Toyota or John Deere, but you'll see a number of really great startups here that we love to feature alongside these big companies. So next slide, please. And that kind of leads me into my next point here, which is talking about how does NVIDIA work with startups today? So we've got what's called the Inception program. It's a free, no commitment program that allows us to nurture startups using our platforms. We consider a startup anyone less than 10 years old that's privately held. And so long as you have a working website and a corporate email address, we would love for you to consider joining. There's a number of different benefits, everything from connection to VCs to working with our engineering team, free training courses, free cloud credits through our CSP relationships, and then of course, go-to-market support as well. And I've got just a couple slides here that highlight some of the testimonials that you'll hear from the startups in the Inception program today. Next slide, please. So as I mentioned, just a few things here to touch on. From areas of technical support, we offer things like robotic office hours. Roadmap previews are super, super helpful, as you'll see from this quote from Andrew, for example. Because they're able to get roadmap previews from NVIDIA, they're able to adjust their own roadmap accordingly and be really responsive for when these products do hit the market. We've helped companies with product supply, which has been an issue for us with our Jetson modules. And then I mentioned, of course, access to robotics expertise. That's both through NVIDIA and then, of course, through partners such as eInfochips as well. Next slide, please. And then finally, go to market support. You know, one of the things I mentioned is we love to kind of showcase some of the great work that's happening with robotics startups alongside these really great, big, you know, well-known companies also. And, you know, what that has helped do is drive a lot of business to our startup partners. Ghost Robotics, for example, has said that 15% of all of their business has come about because of introductions that NVIDIA has made to them, either through showcasing their work at our GTC conference or networking events or connecting them directly with customers when we have opportunities to do so. Pfizer has also talked about their ability to network with other startups and also be introduced to other companies, large and small, through the Inception program. Next slide. All right, I guess this is back over to you, Silas.
Yeah, thanks, Margaret. As we wrap up, I want to give kind of a one-slide overview of eInfochips capabilities right from device to cloud. You know, in the silicon engineering portfolio, we can help with, for example, ASIC design, FPGA, or building SoCs. In the device engineering space, right, we can help in the entire product lifecycle engineering, right from discovery, design, or prototyping, even manufacturing. And then some of the things that we covered today, for example, hardware design services, whether it's embedded systems and software or developing for, you know, firmware or BSPs. And also, I think specifically for this particular segment, for example, hardware, software integration, interoperability, those kind of services. In the digital engineering portfolio, like, for example, linking the devices to cloud, right, which is another big need that we are seeing in this segment, is something that we can help with, whether it's application development, remote device management, cloud operations, and the AI and ML services, like, for example, model training, simulation, those kind of areas we can help with as well. And the last one that you see there is the quality engineering. Santosh kind of covered a few of that. Now we can help with end-to-end testing needs that you may have. So with over 25 years of experience in this space, we have reusable frameworks, mature methodologies and processes, and customized tools to help companies achieve faster time to market, faster automation and deployment, reduce your cycle time, and reduce your cost of rework as well. And the last point here is about the strategic partnerships that we have with platform providers like NVIDIA, Qualcomm, and Analog Devices, NXP, and TI, the cloud partnerships that we have with AWS and Azure and Google, the partnership that we have with NewCurrent for wireless charging and UiPath for RPA, and Tricentis for the test automation, the intelligent test automation. Now, these strategic partnerships help us not only to kind of have access to the product roadmaps, but it also helps us to build expertise proactively and gives us the ability to build next generation AI and edge computing solutions using the most emerging technologies in the area. Next slide, please. So in terms of next steps, right, number one, we request you to, sign up for an eInfochip consultation. We are actually giving away 1 hour of free discovery workshop to the first 10 companies that reach out to us. This can be really valuable to you because It'll help you to determine some of the specific problem areas that you may be having and possible solution options that, to address those challenges. Number two, we ask for you to sign up for the NVIDIA Inception program that Margaret talked about. Again, there's a lot of advantages for you to be part of that network. And lastly, attend the robotics office hours once a month, from NVIDIA and eInfochips. So please, you can contact me and, for any of these next steps, and I'll be delighted to help in these areas. A couple things. This recording link will be sent to Mass Robotic residents, so people who were not able to attend can listen to the recording. And lastly, if there are any questions or you need help in any of the areas that we talked about, please feel free to contact me, and I'll be delighted to get the team, to get together and have a discussion with you. We hope this webinar has helped you again, and have a great rest of the day.